Hi, so my name is Beatrice, and for today we will be talking about measurements and explaining measurements. So, first off, we're going to go from standard notation to scientific notation. The difference between the two is that in order for a number to be scientific notation, it's 10 to the power of a certain number. So, for instance, right here we have a standard notation. So we have 437.21, and we want to write it into a scientific notation. So whenever we write to scientific notation, we have to have only one number in front of the decimal point. So for number 1, we will be moving the decimal point from in between the 7 and the 2 to the 4 and 3. So that would be 1, 2, 2 two times we will have to move the decimal point. So whenever we rewrite that, it'll be 4.3721 times 10 to the power of 2, just because we went left 2 times, and as you can see here, whenever you go left, it's positive. Whenever you go right, it's negative. So it'll be 4.3721 times 10 to the power of 2 right there, because we moved the decimal 2 times to the left. Second example is 0.0073. So that's in standard notation as well. We have to write it in scientific notation. So we will move the decimal point so we can have one number in front of the decimal point. So we will go 1, 2, 3 spaces. We will move the decimal 3 spaces. So whenever we write that down, it'll be 7.3 times 10 to the third, to the negative third, because we moved right, and whenever we move right, it is negative. So the first one we moved left, it's positive. The second one we move right because the exponent will be negative. Okay, third example is 6,353. So since that one doesn't have a decimal point, numbers usually have a decimal point at the end. So let's pretend there was a 0.0 at the end. So let's pretend there's a 0 right there, and so you can see the decimal point right there. So we only want to have one number in front of the decimal point. So we will move 1, 2, 3 spaces to the left, and since we're going to the left, it'll be positive. So whenever we write that, it'll be 6.353 times 10 to the positive 3. Like that. Next, we will be going from scientific notation to standard notation. So for this one, they are already written in scientific notation. We just have to put them in standard notation. So right here, you can see that there's it's 3.915 times 10 to the third. So since the 3 is positive, that means that we already moved left. So we would just have to move to the right since it's the opposite. So it's positive, that means we already moved to the left. So we're going to go ahead and move it to the right. We will be moving it to the right 3 times. So first we write out the number 3.915, and then we will go to the right 3 times. So 1, 2, 3. So in the end, we will be ending up with 3,915. So we moved 1, 2, 3, and we ended up with 3,915 right there. For the second example, we will be taking 1.24 times 10 to the negative fourth. So since it's negative, that means that we already moved right, and we just want to do the opposite because we are putting it into standard notation. So let's go ahead and write out the number. So it's 1.24, and since we already went right, we will be going left. So we will go left 4 times because it's a number 4. So 1, 2, 3, 4. So as you can see, there's nothing there, but we will be putting a decimal point right on top of there. And then we will be filling in the spaces. So 1, 2, 3, 4. So in the end, that number right there turns out to be 0.000124, like that. Okay, so now that we are done talking about scientific notation, we will be talking about significant figures, or sig figs. I'll be showing addition, subtraction, multiplication, and division. So for these, there's rules to this, how to count sig figs. So if there is no zeros at all, like this right here, you will count 2. So this one has 2 sig figs. If there's a zero after the decimal, then the 0 counts as a sig fig. So this right here would be 3 sig figs altogether. If there's a 0 in front of the decimal, then that does not count. So this 3, 2, 5 are the sig figs, but not the 0 in front of the decimal. Also, if there's like, let's say 0.0 and then a number, then the numbers will count, but not both of the zeros. So let's say it was like 0.02, there will only be one sig fig, and that would be number 2, because there is a 0 in front of the decimal and a 0 after the decimal as well. Okay, so let's go ahead and get started with these. So right here you can see that there's 3 sig figs in this one, and then there's 2 sig figs in this one. So the answer in the end will have to have the least amount of sig figs. So whenever we add 3.50 plus 2.1, it will be 5.6. So that has enough sig figs for the answer. If it would have been like 3 sig figs or 4, then we would have had to round it in order to get 2 sig figs. So the answer would be 5.6. Okay, so for subtraction, we have 0.325 minus 10.5. So for the subtraction, we have 3 sig figs here and 1, 2, 3 sig figs there. Since the 0 is in between, then that counts as a sig fig. So the most we can have is 3 sig figs, and I got negative 10.175. So we would have to round negative 10.175 to a number that has 3 sig figs. So it would be negative 10.2, since it has 3 sig figs there. And then next up is multiplication. So we will go ahead and put in the calculator 33.1 minus 3.1 is 30. So right here you see that there is 3 sig figs there, 2 right here. So the maximum we can have is 2 since it's right there. And the answer is 30, so we won't have to worry about that. Next up is division. So we have 5.5 divided by 3. And the sig fig that's the least amount of sig figs that we have is 1, so we will have to round it. So what the answer I got was 1.833 infinity, so we would have to round that up to 2. Okay, so the next one that we will be talking about is rounding. Rounding's pretty easy, pretty simple. So there's a certain rule for it. If the number that you're rounding is 5 or more, then you round up. If it's less than 5, then you round down. So for the first example, we have 7.95. So the last number is a 5. So we'll have to round up, but since 9 is already the highest it can go, we would have to make that 8. Since if you round 90 up, it'll be 1, so you would put 7 plus 1, which is 8. Second problem is 3.25. So that one as well has the last number is 5. So if it's 5 and up, we round up, and if it's lower than 5, we round down. So 5 is 5 or more. So we would round up to. We would round the number 2 up to a 3 since we're rounding up. So this would be 3.3 since we're rounding the number 5 up once. Next we have 5.53. So since we're rounding, the 3 is less than 5. So for that scenario, we would have to round down. So in the end, it would be 5.50, like that. Fourth example is 11.819. So if we want to round up, 9 is bigger than 5, we would round up, so the 1 would become a 2. So we would have 11.82 in the end. Lastly, 29.32. Whenever we round, 2 is lower than 5, so we have to round down, which would be 29.30, like that. So if it's higher than 5 or more, you round up. Lower than 5, you round down. So lastly, we will be talking about density. So for density, we would have to have mass and volume in order to find out the density. So the formula for that to find density would be D equals M over V, and then the other way around. So in order to find out mass, it would be D times V, so density times volume. In order to find out the volume, it would be mass over density. So I'm going to go ahead and keep that with me because that's important information. So for the first problem that we have, it says, what is the density of a pin if its mass is 1.3 grams and its volume is 1.21 centimeters cubed? So we already have, it gives us the mass, which is 1.3 grams, and it gives us the volume, which is 1.21 centimeters cubed. So, going back to this, we need to find out the density. So let's go ahead and write out D equals M over V. I might just use this one. So D equals M over V. Okay, and then so D, which we don't know yet, is equal to M, which is 1.3 grams. So 1.3 over 2.21, which is the volume. Or 1.21, sorry. So now we just need to divide those two and we will get the density. So let me go ahead and do that. Oops. So we have 1.3 divided by 1.21. Which gives me 1.0743817. We can just go ahead and put 1.1 if we round, since the 7 is bigger than 5, so we go ahead and round up. So D equals 1.1. But remember, you have to put the label. So since it's density, we would put grams and the centimeters cubed. So it'd be, since we divided the grams to the centimeters cubed, we would put grams divided by centimeters cubed, like that. Okay? So next up, we have the problem that states a diamond's mass is 15.3 grams. If its volume is 2.41 centimeters cubed, what is the density? So this one's asking for the density as well. We will go ahead and use this formula again. So let's go ahead and write down the formula just so we can get used to seeing the formula, and it helps with memory as well. So we have 15.3 grams, which is the mass. So let's go ahead and put 15.3, and it's over the volume that is 2.41. D equals, sorry about that, so D equals 15.3 over 2.41. So let's go ahead and divide that. Okay, so 15.3 divided by 2.41, and we get 6.348. So we will go ahead and round that, and we'll just go ahead and put 6.35. And remember that we have to also label it, so it would be grams divided by centimeters cubed, like that. Okay. So problem number 3 states that the density of a cube is 8.96 grams divided by centimeters cubed, and has a volume of 1.4 centimeters cubed. What is the mass of the cube? So for this one, it's asking for the mass. So from what we, the formulas that we saw, mass equals density times volume. So in this case, the density is 8.96, and then the volume is 1.4. So times 1.4. So if we put that in the calculator, 8.96 times 1.4 equals 12.544. So let's go ahead and just round it, and we will get 12.5. And since it's the mass, it'll be grams. So 12.5 grams is the answer. Okay, number 4 says, what is the volume of a cylinder that has a mass of 5.25 grams and a density of 1.5 grams divided by centimeters cubed. So this one gives us, so in the beginning it already says that we need to find out the volume. So the formula for that would be V equals M over D. Okay, so the mass that it gives us is 5.25. So 5.25 over the density. So the density is 1.5. So in that case, we're going to go ahead and divide those and see what we get. So 5.25 divided by 1.5, which is 3.5. So the volume for this problem would be 3.5 centimeters cubed, like that. Okay. So the last question that we have for density reads, the density of a bottle is 5.31 grams divided by centimeters cubed, and its volume is 2.56 centimeters cubed. What is the mass? Okay, so it gives us the density and the volume. We just need to find the mass. So the equation for that again is M equals D times V, like this. That's the formula. So we don't know M, but we know that the density is 5.31 and the volume is 2.56. So we just need to go ahead and divide those. So 5.31 divided by 2.56, which gives us 2.074. We're going to go ahead and round that up to 2.1, sorry, 2.1. So M equals 2.1, and since it's the mass, it'll be grams, like that. Okay, so that concludes the measurement section of chemistry.